Okay, I welcome you guys all back to the Nutri tutorials. So basically, with today we are going to continue with our quantitative methods. So now, with the topic we are going to treat today is called, or it's labeled as linear programming. So now, with linear programming, now one would ask, what then is linear programming? Okay, so with linear programming, it's a mathematical technique for maximizing or minimizing a linear function of several variables, such as output or cost. Now, with linear programming, we have ways we are going to develop a linear programming model. So some of the ways we are going to use in developing the linear programming model are labeled below. So one, pertaining to this topic, linear programming, we need to understand what an objective function is. Now, another name for an objective function is called a profit function. So this is how the objective function is being given. You have this. F is equal to ax plus by. When we are solving practical examples, I would explain how we use this particular formula. So just take note that objective function is the same as what? Profit function. Now, dealing with the same topic, we are going to come across what we call constraint, which is the same as subject. Now, most of the times, what we know is when we say maximum, it means greater than, and when we say minimum, it means less than. But with respect to this particular topic, which is linear programming, where you see maximum, the actual thing, yes, that's correct. The actual thing we know is maximum means greater than. But per this topic, when we are dealing with anything concerning maximum, it rather means the inverse. So in a question whereby you see, or in a question whereby you are given a maximum input, meaning that we use the opposite, which is what? Less than or equal to. Okay, in that same question, when you are given a minimum, minimum means less than, but with respect to this particular topic, which is the linear programming, it's rather greater than. That's how we do it. So if it's maximum, which is greater than or equal to, its opposite is what? Less than or equal to. If you are giving minimum, we don't use the concept of minimum, but rather use what? Greater than or equal to. That is the whole concept. When we are solving practical examples, I would explain where we use the maximum and where we use the minimum. So another way they can frame a question pertaining to the maximum is they would use highest. Now, with a minimum, in case you don't see minimum, you would see economically. It's the same thing. Now, with this maximum and minimum, when you are solving it, we know with maximum, we rather use less than or equal to. And with minimum, we rather use what? Greater than or equal to. Now, as that same way that with maximum, we have a value we use to represent it. So if it's maximum, we use Z or the profit symbol. Then if it's minimum, we use C. Now one would ask, but per the profit concept I know is, whenever I'm dealing with profit, I know we have fixed cost plus variable cost times quantity. We use that concept when you are dealing with production. We don't use that concept here. So with this topic, we have two ways of getting the profit function in this question. It's either we use this concept, the objective function or the profit function, or we use the concept of selling price minus cost price. So this is basically the overview of linear programming. So we will dive more into the practical aspects so that you get to know how we deal with this topic.